Good afternoon. I'm Professor Barnard, a senior consultant with HIM Links Incorporated, and today we're going to review some more anatomy and physiology that's associated with ICD-9-CM as well as ICD-10. As future professionals in this field, it's important to know medical terminology and the anatomy and physiology that you'll be working with on a daily basis. Today we want to touch on the respiratory system. Specifically, we want to work with the lungs. Now, the last lesson that we presented, it was on the heart. And the heart, of course, is very intimately linked with the lungs. The respiratory system is going to be Chapter 10 of the new ICD-10 guidelines. And it's pretty ironic, I think, that Chapter 9, the circulatory system, Chapter 10, the respiratory system, pretty much not only is it follows suit in ICD-10, but it follows suit in the actual human body as well. Well, in the thoracic cavity, the chest region, we can see that the lungs are on either side of the heart, located here in the center of the thoracic cavity, just slightly offset to the left. But the intimacy between the lungs and the heart, they're so closely related to each other that their location is important, but it could be a hindrance if it weren't for special membranes which surround the lungs to keep it from interfering with the heart's job. The special membrane that surrounds each lung is called the pleural membrane. The pleural membrane is going to surround the lung, and so when the lung is right up against the heart, it doesn't interfere with the heart's ability to expand and contract. And so while the lung expands and contracts, the heart expands and contracts, they all are able to work in perfect harmony together to ensure proper oxygenation of the blood and removal of the waste product CO2 from the body as well. Well, talking about the lungs, we see of course that we have a right lung and a left lung, each enclosed in its own pleural membrane. And one unique thing about the lungs of the heart is that they look like they're just big balloons, but in actuality, they're made up of thousands upon thousands of tiny balloons called alveoli. These alveoli, these tiny air sacs, help increase the surface area so gas exchange, picking up oxygen and ridding the body of carbon dioxide, can occur very, very quickly. We need to have all these little tiny alveoli because that dramatic increase in surface area really speeds up the process of eliminating the carbon dioxide and thus picking up oxygen. If we were to take all the alveoli that make up the lungs and spread them out on a tennis court, it would cover half of a tennis court. That's a lot of surface area, which really improves gas exchange. Well, also looking at these lungs, not only are they made up of thousands upon thousands of tiny alveoli, but each lung has a different number of lobes. This right lung actually has 3 lobes, whereas the left lung has only 2 lobes. Well, the reason why the left lung only has 2 lobes is because the heart, being offset just slightly to the left in the thoracic cavity, actually inserts right into this left lung in an area called the cardiac notch. That cardiac notch, because it takes away some of the interior surface of the left lung, is the reason the left lung has only 2 lobes. Again, the right lung has 3 lobes, the left lung has 2 lobes. Now, these structures, the lungs working in close conjunction with the heart, form the cardiorespiratory system, a system which works together to take air in from the atmosphere, extract the oxygen, and then ultimately take waste products from all of our tissues and expire it out into the environment. Now, when we talk about the respiratory system, we're already mentioning that we get oxygen into the bloodstream, we remove carbon dioxide from the tissues, it's carried through the bloodstream as well. Along with the lungs themselves, we have associated structures which are going to be important in the respiratory function. Those are the structures of the upper respiratory passages. The nasal cavity, which just as the name implies, includes the nose, the throat or pharynx, the voice box or larynx, and then the trachea, often called the windpipe. That trachea is going to carry atmospheric air from the pharynx, from the larynx, down to each individual lung. That trachea divides into two large respiratory passages, a right main stem bronchus and a left main stem bronchus. And those bronchus are what ultimately are going to carry the air into the lungs, which we extract the oxygen from. If anybody's ever heard of a respiratory infection, oftentimes respiratory infections are associated with these airway passages. These airway passages are vital for the lungs to do their job of taking in atmospheric air and exhaling carbon dioxide to get rid of the waste product CO2. Just to review our lesson today, we have two lungs located in the thoracic cavity. The lungs surround the heart. Each lung is encased in its own membrane called the pleural membrane. That membrane helps the lung to do its job without interfering with the heart, which it's so closely related to. The right side lung has 3 lobes. The left side lung has 2 lobes. The reason why? The heart is offset to the left and it fits into the cardiac notch of the left lung. Finally, we have the airway passages that lead to the lungs. They are the nasal cavity, the pharynx or the throat, the larynx or the voice box, the trachea, and the right and left main stem bronchus. These airway passages allow air to move into the lungs where oxygen is extracted and CO2 to leave the lungs and be exhaled out of the body. Well, I hope you enjoyed this lesson on the respiratory system. We look forward to seeing you again. Please check out our site, himlinksincorporated.com. Thank you.